to continue looking at factoring, and so far we've looked at GCF, difference of squares, and grouping. Now we're going to start looking at factoring trinomials, and these specific trinomials are just when our a value equals 1. So we're just going to factor when a equals 1. So for example 1, I've got x squared minus 5x minus 6. Okay, and that a that I was talking about is like standard form, where we have ax squared plus bx plus c. And so I really don't even have an a. A is just 1. I don't have any other coefficient out front. So whenever you have a as 1 and you have 3 terms, all we're going to do is look for 2 numbers that are going to multiply to get my c value and add to get my b. Alright, so you're going to multiply to get c, and you're going to add to get b, whatever your b and c terms are when it's in standard form. Alright, so for us, we're going to make a little chart. I want to add to get negative 5 and multiply to get negative 6. There's my b term, there's my c term. So I'm going to start by looking at the c's, what multiplies to get c. So to get negative 6, well, I could have a negative 1 and a positive 6, a positive 1, negative 6, a negative 2, positive 3, and a positive 2, negative 3. So if I add all of these up, right, negative 1 plus 6 is going to give me a positive 5. That's not what I want. A 1 and negative 6 is going to give me a negative 5. That's what I'm looking for. Negative 2 and 3 gives me a 1, not what I want. And a 2 and negative 3 gives me a negative 1, not what I want. So my winner is a 1 and negative 6. So all we're going to do is plug those into our parentheses. So I'm going to put an x in the first one, an x in the second one. I'm going to put a positive 1 and a negative 6. That's all you have to do. You can always check your work by multiplying it back out. So if I were to do FOIL, x times x is x squared. X times negative 6 is negative 6x. 1 times x is 1x. 1 times negative 6 is negative 6. Combine my like terms and we get x squared minus 5x minus 6, which is where we started. So here's another example. I've got x squared plus 14x plus 45. So I want to add to the b term, multiply to the c term. So make my table. I want to add to 14, multiply to 45. I'm going to start with my factors of 45. So I've got 1 and 45. I've got 5 and 9. I've got 15 and 3. Alright, and then technically I also have a negative 1 and negative 45 and a negative 5 and negative 9, because 2 negatives is going to give you a positive. But because I'm adding to a positive 14, I don't have to worry about those for this case. So 1 plus 45 is 46, 5 plus 9 is 14, 15 plus 3 is 18. So my winners are 5 and 9. Go to my parentheses, I put an x in the first one, x in the second one, a positive 5, and a positive 9. Again, you could check your work by multiplying back out. We'll do this one using the box method. So I've got an x and positive 5 up top, and an x and positive 9 down the side. X times x is x squared, x times 5 is 5x, x times 9 is 9x, 9 times 5, 45. My like terms are diagonal. X squared plus 14x plus 45. And that's where I started with. We're also going to solve by factoring. So remember, we've looked at the quadratic formula, which works every single time you have a quadratic that you're solving for. But factoring is also a method, right? And sometimes factoring can be a lot easier if it's something that's easily factorable, as opposed to plugging everything into the quadratic formula. So I'm going back to this example we just looked at, but now I want to solve. So I remember we factored this one to become x plus 9 and x plus 5. And this has to equal 0. Before you can factor or solve by factoring, you've got to make sure it's in standard form and set equal to 0. Right? So if you think about this, this is a product. This is my factor 1 times factor 2 has to be equal to 0. Well, the only way that two things are going to multiply and equal 0 is if at least one of them is 0. Right? So I've got two options. X plus 9 can be 0, because then that would be 0 times x plus 5, which would give me 0. Or x plus 5 could be 0. So then I would have x plus 9 times 0, which would also give me 0. So because I have two options, I have two possibilities for x. Let's see if I get this out of the way. So I have one option when x plus 9 equals 0, and one option when x plus 5 equals 0. And now I can solve and figure out what x needs to be. So I subtract 9 from both sides. X equals negative 9. Subtract 5 from both sides. X equals negative 5. So my solution set, if I were to solve this by factoring, would just be negative 9 and negative 5. So now I'm going to do that for this one. We've got x squared plus 16 equals 10x. Before I can solve it in any way, whether it's quadratic formula or factoring, I've got to get it set equal to 0. So I'm just going to move the 10x over. That cancels. It doesn't combine with anything on this side. So I've got x squared minus 10x plus 16. Now I'm going to factor it. I want to know what multiplies to get this 16 but adds to get negative 10. So my table over here, oops, I don't want to put that in. I want to add to negative 10 and multiply to a positive 16. Okay, so I've got 1 and 16, 2 and 8, 4 and 4. 1 plus 16 gives me 17. 2 plus 8 is 10. 4 plus 4 is 8. Well, none of these add up to negative 10. But remember, if you're multiplying to a positive, you could have two positives or two negatives. So I could have negative 1 and negative 16, negative 2, negative 8, and negative 4 and negative 4. Negative 1 plus negative 16 is negative 17. Negative 2 plus negative 8 is negative 10. And negative 4 and negative 4 is negative 8. So my winners are negative 2 and negative 8. So I put my two parentheses with an x and my negative 2, negative 8. Now I have to go that extra step of solving by setting each one equal to 0. So x minus 2 equals 0. X minus 8 equals 0. Add 2 to both sides. X equals 2. Add 8 to both sides. X equals 8. So my solution set looks like 2, 8. Now remember, whenever we solve these, we're also finding the x-intercepts of our graph. So that means that this one's going to have an x-intercept at 2 and at 8.